Hi students. In this lecture, I am going to discuss previous year's IIT questions. Let us see first one. See the question given. The resistance of a conductor is 1 ohm at 300 Kelvin. Its resistivity is, it is given, resistivity. Find at what temperature its resistance is 2 ohm. Okay. See how to solve it. Given 1 ohm at 300 Kelvin. Resistivity is 0.00125 SI unit means per degree centigrade. At what temperature it is? 2 ohm. Right. Right. See how to solve it. If you remember, we have discussed variation of resistance with temperature. That is R2 equal to R1 into 1 plus alpha delta T. Given it is R1, that is 1, and R2, 2. So 2 equal to 1 into 1 plus alpha value. Alpha is given 0.00125, right? It is a per degree centigrade. That means I can write it is 125 10 power minus 1, 2, 3, 4, 5, 10 power minus 5 delta T. T minus 300 Kelvin, right? Then see what we get here. So 2 minus 1, that is 1. So remaining is 125 10 power minus 5 into T minus 300 is equal to 1. From this T minus 300 is equal to, it is 1 by 125 into 10 power 5. So this will be 800. That means T value 1100 Kelvin. Okay. If you want in centigrade, then subtract from here 273. Okay. So this is our answer, right? See next one. An electric bulb rated for 500 watt at 100 volt is used in a circuit having a 200 volt supply. The resistance R that must be put in series with the bulb so that the bulb delivers 500 watt is, okay. This is given for 2 marks in 1987. So this delivers a 500 watt at 100 volt, but it is now given 200. So how much we have to connect in series with the bulb? So first write down the given data. So given its power 500 watt, it is at 100 volt, but we are supplying now 200 volt, right? You can take circuit here. Suppose this is now a bulb and we are connecting one resistor which we have to calculate. Now providing here a supply of 200 volt. This is 200. So we are knowing that this is the power at 100 volt. That means across the bulb we have to get it is only 100. So this is a 100 means this is also 100. So dividing equally means resistance of the bulb or this instrument should be same as this R. So both must be same. Okay. And resistance of the bulb, that resistance is given by R equal to, we are knowing that P equal to V square by R. So R equal to V square by P. So V value, it is 100 whole square means into 100 and P given 500. So two zeros and this is here 20 times. That means R value 20 ohm. This is now resistance of this given device. Okay. That means if you add same resistance, then this voltage divides equally. That means R value must be equal to 20 ohm. Then it divides equally. Okay. It is very simple question. Let us see now next one. Let's see what is given data. A heater is designed to operate with a power of 1000 watt in a 100 volt line. It is connected in combination with a resistance of 10 ohm and a resistor R to a 100 volt mains as shown in the figure. This is now given diagram, right? Now question is that what will be the value of R so that a heater operates with a power of 62.5 watt, right? Let us see once. Given 1000 at 100. This is a 10 and R value we have to calculate so that it delivers 62.5. See how we are going to solve it. So first note down the given data, the circuit diagram. Given this is a 10 ohm connected to heater, and across a heater we are connecting one resistor, that is providing a supply of 100 volt, right? And given that the heater is designed to operate with a power, given power of the heater is, it is 1000 watt. At what voltage? At 100. Okay. Now we have to find the value of R so that it will consume power, that is 62.5 watt. Okay. So this is the given data. Let us see how we start this one. Right. Now we can see first of all what is the condition here. Resistance is at 10. First I'm calculating here for what value of voltage across this combination its power will be 62.5. Okay. So first of all I'm calculating here resistance of the heater. So power equal to V square by R. From this R equal to V square at 100. So 100 square P value it is given 1000. That means R value 10. Right. So this is now resistance of the heater. Right. Next. Let us see power consumption is 62.5. So 62.5 for this corresponding operating voltage that we have to calculate now. So take it as V dash. So V dash square P equal to V dash square by R. R value it is 10, right? So across this combination, potential difference is I'm taking as V dash. This potential difference. Okay. Then see how much we get. V dash square. Or from this V dash equal to 625. So V dash is 25. That means across this combination, if potential difference is 25 volt, then this will consume a power of 62.5 watt, right? Now question is just like we have resistor 10 ohm. Here the total value must be how much? So that here we get now 25 volt. Okay. I will redraw here. This is a 10 and this value we have to calculate. This total value is now 100. So this must be 75 volt and this must be 25 volt. This is a 10. This is one value is given. Sorry, this value we have to calculate. For the heater, it is a 10. So effective value, how much means here? Here effective value, since both are parallel, 10R by 10 plus R. 10R by 10 plus R. So since these two are in series combination, current is same. So V proportional to resistance. So I am writing here. V proportional to resistance. So V1 by V2 is equal to R1 by R2 in the place of R2. 10R by 10 plus R. Okay, V proportional to R. Series combination. Now 10 gets a cancel. Right. This is now here 3 times. Therefore, it is now 3R equal to 10 plus R. That implies 2R equal to 10. So R equal to 5. So this is the resistance we have to connect so that across the combination, potential difference will be 25 volt. For this potential difference, it will consume 62.5 watt. Okay. So this is the answer, right? Let us see next one. Let's see the question given. In the circuit shown in figure, the heat produced in the 5 ohm resistor 5 ohm resistor due to the current flowing through it is 10 calorie per second, right? The heat generated in 4 ohm resistor. Let us see how to start it. We are having 4 and 6. This is a 5. Okay. In 5 ohm given 10 calorie per second. We have to calculate now in 4 ohm how much. Right, let us see. Let's take a diagram given. Given that 4, 6, 4 ohm, 6 ohm. This is now 5 ohm. Current enters here. Right. Now through 5 ohm resistor, heat produced is at what rate heat produced at? That is given as 10 calorie per second means power, right? I square R. So we have to calculate now heat produced at what rate across the 4 ohm resistor, right? So we are knowing that this heat produced means we can say power equal to I square into R, right? I square into R. Now see what we can do. If this current is now I, see this is a 4 and this is 6, total is a 10. This is a 10 and this is a 5. So current divides in the ratio 2 is to 1. Means in this current will be 2I by 3. And in this current will be I by 3. Right? Now power developed, right? Across 5. I square R. I am taking I square R. That is now I value 2I by 3. I square R value 5. This is given as a 10. Okay. Now we have to find across 4. Across 4 means current is now I by 3. So I by 3 whole square into its resistance is a 4. So this value how much? This value how much? Suppose take it as H. At what rate heat is produced? Let us take ratio here. I think this is more simple, right? I by 3 whole square. I by 3 whole square gets cancelled. Remains of 4 here. 4 and 4 gets cancelled. So 5 here 2 times, right? That means H equal to, this is over, this is over. So H equal to, it is 2 calorie per second. Okay. So like this, we can solve it. See the answer. It is option B. Okay. Right. See next one. See what is given. For the resistance network shown in the figure, choose the correct options. This is asked in 2012 advance. See how to solve it. So first see the conditions. Current through PQ is 0. Current through PQ is 0. I1 equal to 3 ampere. Potential at S is less than that at Q. And I2 value 2 ampere. See one thing you can see carefully. Circuit is now symmetric. That means 2, 2, 2, 4, 4, 4. Right? That means what we can say is now here, potential at P and potential at Q both will be same. That means we can remove now this resistor. Okay. In the same way, at S and T, potential same. That means we can remove this resistor also. So once we are removing these two, remaining is now only 2, 2, 2. This is a 6. This is now 4, 4, 4. This is 12. 6 and 12. Now these two are parallel. Okay. Let me draw a diagram once. Right. See a circuit diagram once given. And next bottom one, it is a 4. Again 4. This is again 4. So 2, 2, 2. 4 ohm, 4 ohm, and this is also 4 ohm. Right. This is connected to 12-volt battery. So here what we have done is this is given P and this is a Q. And next this is S and this is T. Okay. So here what we have taken that at P and Q, same potential. S and T, same potential. That's why we have removed now these resistors. Right. Therefore, remaining 6 and 12, those two are parallel, are effective. 6 into 12 by 6 plus 12. This is 3 times and 3 here 4 times. 4 ohm. That means current will be, this is given as I1. So I1 equal to, it is a 12 by, this is given 12 volt, 12 by 4. That is now 3 ampere. Right. Next, coming to here, divides into two parts. And this current, it is given as I2. You can see this is now 6 and this is 12 in the ratio 1:2. Since they're parallel, parallel means V equal to IR, V value same. Therefore, I proportional to 1 by R. I proportional to 1 by R. So current divides in the ratio, it is 2:1. So two parts here and one part here. That means this will be 2 ampere and this will be 1 ampere. Okay. That means I2 equal to 2. Option D correct and B also correct. And current through PQ, it is now 0. That is correct. Now let us see option C. The potential at S, that is S, is less than that at Q. Okay. Comparing potential at S and potential at Q. Right. Let us see. Suppose I'm taking this is 0. Then this will be 12 volt, right? Because the potential difference is 12. If this is 0, this will be 12. Now what we can do is, here 2 ampere current is a flowing. So 2 2 to 4. 2 2 to 4 means at yes, potential will be 4 volt. Okay. Next, coming to Q. I am taking here, current is 1 ampere. So 1 into 4, it is a 4. So potential decreases by 4. So at a Q, it is a 12, 12 minus 4. That is 8. 8. So it is given that potential at S is less than that at Q. So option C also correct. That means correct options are A, B, C and D. Okay. Right.